All right, so we're going to take a look at a problem with data, and these are a random sample of 16 HMOs. And for each of these HMOs, they recorded the copayment in dollars for a doctor's office visit. All right, so if we're given the data, we're going to enter that data into our calculator. So I generally just use the first list. So we've got our data. Under the assumption that copayment amounts are normally distributed, so this statement is required because the sample size is small. So anything under 30 is called a small sample size, and of course 16 is less than 30. So this is just a requirement in order to continue with either the Z or T interval. All right. So we want to find a 90% confidence interval for the mean copayment amount in dollars. So we are estimating a mean. That is going to change soon. So I know that's all we've been doing so far, but for now, we are still estimating means. Our sample size, so symbol lowercase n is our sample size, n is 16. What is the best point estimate of the population mean? So I just want to do one bar stats to find that before we talk about the interval. So the point estimate we know is the corresponding statistic, so sample mean. So if we do one bar stats with that first list, there's my sample mean. I'm going to round to 1 decimal place, so that would be 8.4. Okay, now we're going to create the confidence interval, and you'll see now that I've done one bar stats, there's an S and a sigma here, but in this problem, they gave us the data and they never said anything about standard deviation. So they did not give us the population standard deviation. They actually didn't give us the sample standard deviation. But the idea is that population standard deviation, sigma, is not provided. So if we don't know sigma, that's when we have to rely on the t distribution. Now, the sample standard deviation, we always know that because we have sample data. So that S is the relevant one. Sigma here is just wrong. This is not population data. So the sigma is a meaningless number on the screen over here. That S is the standard deviation of the sample. Now, I don't want to actually write that number down and round it, because when we have data, in order to be the most accurate we can be, we're going to let the calculator just work with the data. So let's do that. So population standard deviation sigma is not provided. And that means that everything will be based on the t distribution. So it's a t interval that applies. So when you go to your t interval stat tests, number 8, we're not going to enter X bar and S. But you can see right now on my calculator, because I just did one bar stats, the calculator put those numbers in anyway. All right, however, you don't always need to run one bar stats first. So generally what we do is when we have data, we change our input to data. We know where the list is. L1 is our data, and frequency 1, that never changes. Confidence level, 90%, we've got that. So if they give you data, let the calculator work with the data to avoid rounding problems. So this will be the most accurate that we can be. So our confidence interval, we're rounding to 1 decimal place. So 7.4. Less than mu, less than 9.5. Okay, and then we'll just write the sentence. So I can estimate with 90% confidence that the true mean copay, so this was based on 16 HMOs. We believe this is the mean for all HMOs, so that the true mean copay for all HMO doctor office visits, doctor's office visit. See if that sounds right. We estimate with 90% confidence that the true mean copay for all HMO doctor's office visits is somewhere between, so this is money. I know we rounded to one decimal place, so that would be $7.4 or $7.40, but we're not going to be accurate to the nearest penny there. We're just going to do one decimal place. So $7.4 and $9.45. And the dollar sign looks weird there. It's so small. I'm just going to write the word dollars. So I like that better. Between 7.4 and $9.5. All right, so again, with technology, pretty easy to find the confidence interval. Your job is to figure out, did they give you sigma? If they do, use a Z interval. And if they don't give you sigma, we go with a T interval.